Okay, so we'll discuss about machine learning. We learned some machine learning stuff, but before we see the actual machine learning stuff, so we just get some preview of what could be the machine learning. Why do you call it machine learning? This kind of stuff. But we'll see a little bit history here. So I'm Atiq Ahad. Welcome to this lecture. So we know that now ChatGPT is extremely expanding. We are using at this moment, right? But uh, it is just a part of this expanding AI landscape. So this landscape is given by someone. It's not like the standard one that everybody will agree upon. But let's see what is here. Okay. By the way, I mean, if you are AI person, then you shouldn't talk about it. Shouldn't talk everything as chat GPT, because these are basically large language models, LLM. So it could be chat GPT, it could be Bing AI, chatbot, or Bard, or maybe something if I developed then Atiq Ahad GPT or something, all right? So the broadly we know that AI and this is machine learning, and within machine learning is deep learning, and within deep learning we see the generative AI or Gen AI or so on. And then we see different kinds of large language models which are based on one of the major deep learning models, which we call transformers. And actually, GPT, you can say this is a generic term, like generative pre-trained transformer. So GPT is not owned by any group. But when you call it Chat GPT, then it's a different thing. Okay. And so on. So these are the different things. So, but what about above AI? What could be covered? Statistics, mathematics, or philosophy as a whole? Yeah. So AI is encompassing different domains. So make sure that if you want to know how genuinely AI works, the inherent mathematics statistics, then you must study stat and math rigorously to understand, especially the machine learning and deep learning and so on. Philosophical aspects, social aspects, ethical aspects, humble AI related things. I mean, you may not be a master of those things, but if you understand the models better, then you definitely comprehend many things, which is not easy from outside. So AI, and then we say machine learning, which is now we call shallow machine learning, not deep. And then we have machine learning, which is super deep, so we call it deep learning, and generative AI, large language models like GPT, generative pre-trained transformers that we see outside and in the buildings, like called transformers, right? No, this is not the transformer we are talking about. Okay, so this is not even this kind of transformers. Okay, I don't know whether you watched some of the movies, but I didn't, so I don't know whether these are just like amazing or just like cartoonish fighting. So these are not the transformer. So transformer model are nothing but having an encoder and decoder combination, and it can do like this. And for example, this is a language using transformer something something, and decoder is producing it's Japanese. So probably this is German, this is Japanese language. Now, transformer are a type of deep learning architecture, and they are particularly well suited for NLP, natural language processing tasks such as machine translation, text summarization, question answering, and so on. So, in the natural language processing domain, but deep learning, CNN-based models versus the transformer-based models, and so on. So it has other applications in other domains like image recognition, speech recognition. Recently, we published a couple of papers, in both papers on autistic children's facial expression or face-based understanding or recognition. We also use different kinds of transformer models to explore, but definitely the NLP is used is the leading one. Now, why do you call machine learning? So machine here is computer based, anything where it has computer capacity or something, and just like, so instead of machine, if you put human, so human learning, so human, how human learns something versus how can you teach a machine, a computer via programming language, okay, and then so that the language finally can understand something. Okay, remember that human intelligence or animal, some of the animals, their intelligence are super high, extreme, diverse, and lots of things are there. But the machine learning models, which is now engulfing deep learning models, are improving and so on. So sometimes in some research papers, you will find that they say machine learning, but we consider those as a classical machine learning, and if they mention deep learning, then it's deep learning, but both things are under the belt of machine learning. So sometimes machine learning is used, only for machine learning, classical machine learning, and sometimes machine learning term is engulfing deep learning as well. So make sure that what they mean in the literature. Now, in the terms of learning, how do we learn in real life? So normally, machine learning algorithms are trained in the not in the field to go to the war, okay, or not to make how to make breads, for example. They are trained on computer using large amount of data. So if you have lots of data, you train your model or algorithm so that it can understand some of the patterns and can make predictions. Now, for example, if I show you 1,000 Japanese photos, 1,000 Korean photos, 1,000 Vietnamese photos, and Chinese photos, for example, or images, so similar kind of people, uh, mm, can you understand and differentiate? If I tell you that, okay, this photo is from Japanese, this photo is Chinese, this photo is Vietnamese, this photo is from Thailand, for example, and something like, or Korean. Now, even though they look almost similar to outsiders, but if you look 1,000 images carefully and try to identify some of the common patterns one country, one nationality has, and another different, and try to this kind of things, then and then make predictions. So now when I taught you 1,000 images, I told you that this image is a Japanese, this 100%, this image is 100% Japanese, this is image 100% Japanese, this is Chinese, this is Korean, this is Vietnam, and so on. Now, you already found some patterns. Now, uh, now after the training, your training is done. Now you are in the war. So I gave you one image. I told you that this is a Japanese, this is a photo. What do you think? Is it Japanese, Korean, Chinese, or Vietnamese? Now, based on your previous training, if you are trained well, you can more accurately classify or make your predictions about the new unknown photo, okay, and vice versa. So that's the point. So assume that your robot friend is Atiq, okay, and you want to teach Atiq how to recognize different kinds of fruits like apples, oranges, and bananas. Instead of giving Atik a list of rules or instructions, you show him a bunch of pictures of each type of fruit. And as Atik sees more and more pictures, remember, as in life, we don't train forever. We have a time that, okay, only 1 year training or maybe 3 months internship and training, and then you go to the job. So similarly, there is a limit. We don't train something an abnormal amount of time, be realistic. So as Atik sees more and more pictures, he starts to learn the patterns or relationships or some try to connect some graphs or mathematical connectivity within my mind and brain or the robot and try to distinguish each fruit. Eventually, what happens that when something new fruits comes without any further instruction, Atik tries to understand and identify. So this is similar to how machine learning works. Okay, so that's the point. So ML algorithms are trained usually on large data sets. By the way, you will see that some machine learning algorithms you have no training, without training. So we call it, unsupervised. But when we say that trained on large data sets, basically we always think about huge amount of data sets and so on, which can be images, text, or any other types of data. So always think how human learns and whether we can mimic the whole concept to the machine learning models. As the algorithm is exposed to more data, it identifies more patterns and better predictions. So, for example, if I train you, say you are an algorithm, and I train you that this is cat, this is dog. Now, just when I went to Japan, I noticed that the cats, there people have small things. Okay, animals, they are walking and so on. We thought initially that all are cats. Then we realized that no, it cannot be cat. Looks like dog, and then even though they are like cattish, but they are basically dog. So, and vice versa, most of the people works with the dogs, not the cats. And when I went to Sydney, in one area, I found that we lots of, big sizes dogs, and I was scared of. And then that dog is different. In my country, dogs are mostly on the street, stray dogs. So you see that based on the experiences, now I can understand, oh, maybe this is a dog, this is a cat, and so on. Even as a human being, I can make lots of mistakes because my examples from where I learned didn't have very tiny dogs as I saw in Japan. So that's the point. So, training is important, and what we train, this is also important. After being trained on enough images, the algorithm will be able to identify new images of cats and dogs with higher accuracy. For machine learning purpose, usually, the first step is data collection and pre-processing. Like you buy vegetables from the garden, and then you need to pre-process it. Like you have to clean the data, if anything unwanted and not necessary, you just remove those, okay, before the training. And remove outliers. Sometimes we remove the outliers like noise and other things. Sometimes we add noises. It depends on the application. And then transforming the data into a format that algorithm can understand. Features and levels are important. So we introduce the concept of features and levels in a dataset. So feature engineering is the process of creating new features from the raw data. So you can say that you have the vegetables, which is raw, or fish, and then we prepare it based on the way I want to cook it. All right. So then we keep the data. Say I have, one box of data, is say 80% or 70% or 85% data will be used to train the person. Because when I train you, I tell you that, okay, this is Japanese photo, this is Vietnamese photo, this is Korean, this is Chinese photo. So you are trained based on this. So training set of the data is called training data set to train. But I trained you. Now I must know whether the training was good or bad, whether you learned something good or bad. So sometimes we go for 5-10% data to validation set. Say in this case, usually not. Then testing set is the, so training and testing are the most two key important part. So rest of the 20% data, or maybe 15% of the data, we can consider to test or to see the performance of the model. Like I trained you with the 80% of the data for 3 months, assume, and then I want to now test you with the 20% of the data. You don't know, your machine learning algorithm doesn't know the level of those data, whether it's a Vietnamese photo or it's a Chinese photo. You tell that, oh, it looks like Japanese. Then as I am testing you, I look at whether it is Japanese or not. You don't know. If it is Japanese, you get 1. If it is not, you get 0, means it failed. So this way, I wanted to see that out of 4,000 images, so if I say 4,000 4K images and taking the 20%, so basically it's 800, right? So 800 images, how many of you can say that this is, good or bad? Right or wrong? Based on this, I can go for the accuracy or some other parameters and so on. Okay. So model selection and training. So select an appropriate ML algorithm. So it may be there are different kinds of algorithms we'll see in the future. So which algorithms you are using and for what purpose? And then the algorithm is then trained on the pre-processed training data set. Model evaluations. So for the model evaluations, we just go for the evaluation, as I mentioned, the testing and so on. When we find that the testing result here, the testing result is also very good, reasonably good, because you can recognize. And if we think that this model can be now move to the market, so we can go for the model deployment. Like if the model performs really well, there is no definition what is the best, because it depends on, we want 100%, but 100% accuracy even in many cases human cannot do. So we need to see that what kind of applications and how much tolerance we can make that accuracy compromise or a poor performance or not. Okay. Like for example, when I talk, if you use YouTube and you get the English word, sometimes you find weird word, sometimes correct one and wrong one and so on, especially. So this is automatically generated. So think about a few years ago, there was nothing. Now we have something. So what happens that even if you can mute the video and then see the English and you can understand more or less what the person is talking, one day will come when it will be 100% accurate and free. So the model performance and evaluation or validation or test data set, what we call it basically, and to see that whether it is performing well or not. And we need to monitor it performance over time so that we can say that, okay, last 2 years, the model performed really well. Right, if you consider ChatGPT and others, I mean, you see that, I mean, they are really good at doing many things than when they started. And the professional version where you pay, like ChatGPT version 4 or probably ChatGPT Plus, I mean, the performance is better. Some companies like Databricks or others, they have their own LLM models. And their performances are more suitable or better for small areas. So it depends on for what purpose you need and so on. Now, what I mentioned so far, it's I mean, it can be 7 steps, it can be 5 steps. It depends how you talk about it. So I just put two different examples. Like data collection is one. Data pre-processing can have many steps, but say data pre-processing, then you select the model and you train it. After training, you evaluate like validation, and based on this, you see that whether you need some tuning. Like if you use the radio signals or radios, I mean, 30 years ago, 40 years ago, you can remember that fine tuning was not needed on that time. Even today, like if you use radar and others, and finally you go for final predictions and go to the market and so on. So that's the thing. So it mentioned that the best source for data collection is Kaggle. Kaggle is a website. You will find lots of data sources. People share their data over there, and you can try to find which data you need and so on. See, similarly, it is a different one, like data gathering, like data collection, data preparation, like data pre-processing, choosing a model, like model selection. Training the model is nothing but training. Gauging the model means evaluation and tuning, fine tuning to make it better, or parameter tuning. And finally, you say that you are done. So model is the same thing. Now I give one example, like for example, this is autism children having ASD, and this is typically developed children, two images. Okay, and this is the input, for example. So and so there are more inputs of two types of like binary decision. Now what we do in the pre-processing, and data augmentation is another term. When you work with data engineers, you will find that they talk about data augmentation, like resizing the image, flipping the image, rotation, noise removal, blah blah blah. Why we do that? Because in real life an image cannot be always like this vertical position. Maybe it is like this way, maybe it is smaller, maybe in a corner or something. So if your data set has more diversity, more data, sometimes we augment so that we can have more data, then we can do. So now feature extraction, it can be based on handcrafted classical features or deep learning based generated features. And finally, we can say which levels it has. All right. Now, and we train the things like this manner. But when you go for testing the data, we finally we have the trained model, and we trace the data on the trained model to see that what is the image. So if we have a new image, we want to see that whether it is ASD or TD, and give another image and see the result, another image, see the result. And finally, we can see that if we have 800 images for testing, then how many times the ASD and TD are properly selected by this model. With that, we finish it. So next we'll see that machine learning categories. There is no professional categories in one sense, but based on their nature of the machine learning algorithms or relationships, we can say that there are different kinds of things. So we'll see in the future. And do your best. Thank you.